right, guys. So for today, we are going to look at adding and subtracting these rational expressions. How do you add and subtract fractions? You have to have a common denominator. That's what makes this so hard, because students don't know what a common denominator is. Okay, so we're going to look at both some that will have common denominators and some that have not common denominators. We'll have to make them common. So let's start with just regular old fractions from back in the day. Okay, so what's 2 sevenths plus 3 sevenths? That's 5 sevenths. So when you have a common denominator, do you actually add the denominator? No, you only add the numerators. You keep the bottom the same. You keep it common. What about 11 fifteenths minus 1 15th? What was it before you got to that point? It'd be 10 over 15. But then you were right, it is 2/3. Right? So if you subtract or add a fraction and then you're like, oh, that can be simplified, then can we simplify it? Yes, we can. And we will do that today. All right, what about number 3? 3/4 plus 5/14. Christian? Yes. Which one are you looking at, hon? Okay, number 3. Mm-hmm. Yes. Then your common denominator would have been a 16. Yeah. Now for this one though, 4 and 14, like I can't turn 4 into a 14. So what would be the common denominator? Guys, I need you to pay attention, please. So what should the denominator be so that I can make them both the same? It'd be 28. Because a lot of times, like, I'm glad no one told me 2. Because every year somebody tries to tell me 2. Can you make them smaller? No. For common denominator, it has to at least be what it is or bigger. You can't make them smaller. Can you turn 4 into a 28? And I can turn a 14 into a 28. Mm-hmm. So what do you have to multiply 4 by to make it 28? 7. So if I multiplied the bottom to make it a 28, what do I also multiply? The top. So that'd be 21. Now, did I actually change this problem? No, if I would simplify this, it'd go right back to where it was. Okay. How do you turn 14 into a 28? So that means I also have to multiply the top. So that gives me 10. Now can you actually add them together? Yeah, what's 21 28s plus 10 28s? 31 over 28. And then that doesn't simplify, and we are done. You can leave them improper. This is basic math from like 4th grade. So I hope it doesn't seem so hard. I'm glad that you think so. Now I'm going to throw X's at you. All right. So let's start real basic. Let's start with some basic ones that have common denominators already. Okay, the hardest part is students to find that common part. So what if they're already common? Adrian, you all right over here? I'm sorry. Can you pull that door shut? We can cut out all that extra noise. Maybe that might help a little. So 7 over 4x plus 3 over 4x. See how it's already common? Okay, so what's the denominator going to be when I add them together? 4x, it stays common. And 7 plus 3 is 10. Questions so far? Yeah. Can I simplify that? Yeah. I can divide them both by 2. Yeah, if I divide them both by 2, I get 5 over 2x. Remember, they're not held with a plus or minus sign, so you can piece them out. It's okay. You can cancel things. All right, what about the next one? What's that going to become? Yeah. On the top, you're going to have 2x minus 5. Those are not like terms. Over x plus 6. Can I cancel the x's? Why not? Good, they're attached with plus or minus, so I can't touch those. That would be as far as that one goes. So if they're a common denominator already, should they be that hard? No, they're not bad at all. Now, the issue where we're going to spend all of our time today is what happens when they're not common. Okay? You can make yourself a little note that if already have common denominator, you would start at step 4. Some people get themselves lost. We spend so much time trying to find the common, and then I give you your homework, and the first part of the homework already has common denominators, and people don't know what to do with that. Okay, so if it already has a common denominator, you're going to start at step 4, where you just add your numerators together and kind of go from there. Make sense? All right, but take a look. We have 7 steps. And I want to point out to you, where do we actually cancel something? The very end, right? Every year I have students go through the process to find a common denominator, and they get the common and they do all the math and they're like, oh look, that cancels. Of course it will. You try to make it a common denominator, of course it'll simplify back to the beginning. We do not cancel anything until the very end. The very end. Everybody got that? The very end. Do not cancel anywhere else. So we are going to factor our denominators. Notice it doesn't just say factor where I factor anything and everything. I'm going to factor only the denominators. I'm going to find the LCD. I'm going to find my least common denominator. That's the part a lot of people will struggle with. Then I'm going to multiply each fraction by the missing pieces to obtain the common denominator. Just like on the previous problem, I multiplied by 7. I multiplied this one by 2. That was its missing piece to make my denominator be what I wanted it to be. Okay? All right. Once I do that, then it's just like what we were doing. I would add my numerators together, collect my like terms. This is where I state my restrictions then. Then I would factor the numerator. So denominator gets factored at the top, numerator gets factored way down here, and then cancel anything I can. Please read your papers, okay? Don't be that student that I walk over to you and you're like, I don't know how to do this, and I literally stand there and read your paper for you. I'm going to be like, smack you upside the head, like, read your paper. You can read it out loud to yourself. It'll be okay. No one's going to make fun of you for reading it out loud. All right, so I got steps right here. You have the steps in front of you. They are all over the place. Please read them. Okay, because every step of this problem, I will read through those steps with you. That's what we do to actually get through it. So step 1, factor the denominators. Do either of them factor? Yeah. This one I can take out 3x. And I have x plus 1. Now, the hardest step for most students is step 2, finding your least common denominator. All right, so my common denominator, I need to make sure every piece is accounted for. Okay? So I have a 9 and I have a 3. So those are just numbers not attached with the plus or minus sign. I can turn both of those into a, what would be the common denominator between 3 and 9? 9. I can't make them smaller. I can make them bigger, or what they are. Right? 9 is already a 9. I can multiply this one by 3. So 9 is going to be part of my common denominator. I have an x and I have an x squared. I can't make them smaller. I have to at least be an x squared. This is where people struggle, is finding this common denominator. So hang with me. We'll do a lot today and tomorrow. We're going to spend 2 days just getting through this, okay? All right, and then I also have an x plus 1. I need an x plus 1. So that would be my common denominator. And again, we will practice this. I know that's the hard part. So multiplying on step 3 by their missing piece. So what does this denominator need to make it look like this? It's missing the x plus 1. Do you guys see that? If I would put an x plus 1 here, now does it look exactly like that? Yeah. So if I did it on the bottom, I have to do it on the top. How do you multiply 7 times x plus 1? You distribute that. 7x plus 7. And then next part, what is this denominator missing to make it look like this? And a 3 and an x. Because 3 times 3 would make that a 9. X times x would make it an x squared. And it already has that. So I'd have to multiply this by 3x, which means I multiply the top by 3x. Good. And again, we will go through a lot of these. I promise you, don't get too frustrated. Just don't tune out, okay? Just hang with me. Yep, so next part, step 4 is to add my numerators. Any of those like terms? No, but does the order bother anybody? Yeah, so let's just put it in the right order. So 3x squared plus 7x plus 7 over 9x squared times x plus 1. No like terms, so I can't really do much. Just put it in the right order. All right, that was step 4. Step 5, what are my restrictions? X cannot equal, remember that it's just where we solve the denominators. Not 9. 0 and negative 1. All right, 0 comes from baby brother out here, and then negative 1 from right there. Step 6, can I factor my numerator? Is that going to factor? It's not going to factor. All right, and then does anything cancel? People try to cancel this all the time, but how is this held? That is held with a plus sign, so I can't touch that. This is as far as this one goes. No. It's held, because this is attached, that whole piece is held with the plus sign. I can't touch it. It's as far as I can go. Again, don't tune out. I know it's hard. That's why we spent a couple days on this, okay? Hang with me. I know there's people that are confused. We're going to do a lot of these. The more you see, it starts to make sense. I promise you. Other questions here? Please ask. I know this is hard. Let's do some more. Don't tune out. Just hang with me, okay? I'll get you there, I promise. All right. Step 1, factor denominators. Either of my denominators factor. Yes. This one does. How does this factor? Good. At any step, if I do a step and you're like, whoa, what just happened? Raise your hand, okay? Don't let me get through the whole thing and then take me back 6 steps, okay? Ask me as we go. All right, step 2. This is the hard step. What is my LCD? Remember, I cannot make them smaller, but I can make them bigger. So I need every piece. That's what I need. Everything needs to be accounted for. So I'm just going to kind of look across. I need an x minus 1, right? Because there was one right there. I need an x minus 2, because there's one of those. Do I need another x minus 1, or do I already have one? I already have one. Now, that being said, we're going to come into a point where we might need more than one of them. But like in this fraction, there was only one x minus 1. In this fraction, there was only 1. So I only need 1. But like if this was x minus 1 squared, we can't make them smaller, right? Then I would need 2 of them. Because that one would have 2, I'd have to have 2 of them in my common. And we'll get to examples like that. All right, so there's my common denominator. I literally just kind of went across and I made sure I had everything accounted for, every piece. Step 3, multiply each fraction by the missing piece. Okay, what is this denominator missing to make it look like this? The x minus 2. Right, so now my bottom would look the same. So that means I need one at the top, x minus 2. And you're going to have to distribute that, and what would you get? Okay. What is this denominator missing to make it look like this? It's not really missing anything. Oh, I could do a 1, but if I multiply by 1, I don't change anything. But it has both parts. So what do I have to multiply? Nothing. I still have a 2x and a minus 1. All right, hold that thought. Let's make sure we're okay on where I wrote it down. I don't want to go too fast. Dakota? I didn't need to multiply it by anything. My denominator on this fraction was already what we said the common should be. It didn't need anything. Yep, it just came down. If it makes you feel better, you can multiply it by 1, but you know me, I'm lazy. There's no need for that. Other questions on me multiplying on step 3. All right, step 4. Let's add our numerators. Do we have like terms or anything? Yeah. So that's going to give me x squared. These will cancel out. Minus 1 over x minus 1, x minus 2. So that was step 4. That said add numerators. That was step 4. Step 5. What are my restrictions? 1 and 2. X cannot equal 1 or 2. Again, restrictions come from just solving the denominator. Step 6, can you factor the numerator? That's a difference of squares, right? So x plus 1, x minus 1. So that was step 6. I factored my numerator. Step 7, the only time you should be canceling anything is here at the end. And yes, I can cancel the x minus 1s. So it's just x plus 1 over x minus 2. The hardest part for students is finding the common denominator and then actually multiplying by what was missing. Dakota? Difference of squares. Yep. Was that one a little better? A little bit? A little bit? Each one should get just a little bit better, I hope. What am I hanging on to? Smartboard? That's what it was, yeah. And then I canceled out the x minus 1s. No, you're fine. Okay, here we go. Step 1, factor denominators. Good. I can factor the x squared minus 4, x plus 2, x minus 2. Step 2 is your LCD. Don't say it out loud. Take a minute, write down what you think the LCD should be. All right, what should my common denominator be? Just x minus 2? And x plus 2. I have to have every piece accounted for because I can't make them smaller. I can only make them bigger. So as I kind of go through here in my brain, I'm like, okay, x plus 2, I need one of those. X minus 2, I need one of those. X plus 2, I already have one of those. Okay, I'm good. I got it all accounted for. Yep. I need every piece accounted for. Why do I not need 2 x plus 2s, though? Right. There's only one here. There's only one here. I only need one then. The most it showed up in any fraction was once. I only need it once. Okay? That was really funny. All right. Here we go. That was step 2. Finding my common denominator. Step 3, missing piece. What is this denominator missing to make it look like this? Nothing. So I'm just going to bring down the x. What is this one missing? So that means I have to multiply the top as well. All right. So we were multiplying that by x minus 2, right? So if you distribute a 1, it's just x minus 2. Good. Yep. So then step 4 is add your numerators. All right. 2x minus 2. Common. These were like terms. 1x plus 1x is 2x. Yeah. X times x is x squared. Yeah. I know. Basic math's hard. That's what it always comes down to, right? Basic math's hard. X plus X is 2X. All right. That was step 4. Read your papers, right? Step 5, restrictions. So plus or minus 2 on the bottoms. Step 6, can you factor the numerator? Take a 2 out. So I have x minus 1. That's why we just need repetition. We'll see these. They start to flow. They all have the same kind of flow to them. And then step 7, does anything cancel? No. Okay, so I'm done. You don't have to remember them. Read them. I told you I'm letting you use it on your test. Yeah, this is the one time I'm letting you use the colored paper on your test. Thank you. All right, questions here? Doing all right? Good. Means you're actually using it. All right. All right. Number 9. Step 1. Factor your denominators. Either of them factor? How's the bottom one over here factor? Say that again. Just take out an x, guys. 5x minus 1. Okay, that is not what I thought I heard from somebody. I'm like, wait, what did you guys just do? I thought somebody was trying to make that a difference of squares or something. Yeah, just take out an x. All right, so common denominator. Do you guys notice how I write this? I want to make sure you're catching on to how I'm writing things as well. Do you notice I write it as just one fraction then? Right? Yeah, I'm lazy, right? So make sure you could be lazy like me. Just write one fraction, we'll just write it all together. Makes things easier. All right, so take a second. You write down what you think the common denominator is. You'll never learn if you just let me just tell you every time. He's cute, isn't he? Bless you. Yes. Just x? So I need both x and x minus 1. Cannot make them smaller, guys. So this is one piece, right? Because it's held with a minus. So I need an x minus 1, and I need an x. Okay? I cannot go smaller. Are we getting that? I cannot make them smaller. It has to be at least that or bigger. Okay, step 3. Multiply by the missing piece. So what is this denominator missing to make it look like that? It's missing an x. So that means I also have to multiply the top by x. So what do we get? You guys with me? That was just distributing. X times x is x squared. Make sure we're clear on that. I know that one's hard to keep track of. What is the other one missing? Nothing, right? It has an x and an x minus 1, which is what I already had. So it's not missing anything. I have a minus 2 right there. Okay? All right, from there. Any like terms? No. Okay. Restrictions? Good. 0 and 1. Again, that's from your denominator, solving those. Step 6, can you factor the numerator? That factors. How's a factor? Yep, we're on factor the numerator. X what? X plus 2, x minus 1. In math, I can't assume I know what you meant. It's not like in English where I'm like, yeah, I can read between the lines. It's kind of gray, right? Like, can you? No, math is you either know it or you don't. I taught this in Algebra 1 when I taught in Finley. Technically, this is Algebra 1.
So what? Do the kids in Finley in this senior year learn how to split atoms for number 2?
That's just, and the big, I think a big part of the difference though is when I taught in Findlay, I had them all year long. I don't have you guys all year. I have you half a year. Just because I have you twice as long every day doesn't mean I can teach you twice as much every day. It's not the way the brain works. You look terrible. All right, step 7, cancel. Good. So then I have x plus 2 on the top and an x on the bottom. Can I cancel the x's?
No.
Why not? Good, that's held with a plus. And I'd have thrown my marker at you. Probably not, but you know. Is it getting any better from the start?
Yeah.
A little bit? What? You want a brain break? Yeah. Okay, here we go, guys. Number 10. Step 1, factor denominators. So how does the first one factor? Okay, take out a 2. So x minus 1. How about the second one? Thank you. Now, something is happening in this problem that we have not yet seen. Besides the fact that they both factor. Look at this problem. Why is this different than the other problems? There's a negative sign. What happens when there's a negative sign in front of a whole group of stuff? It changes all of its signs. Yeah, so guys, before we get going into this problem, anytime you see a minus sign, we know it changes the signs, right? Now, don't do it to the top and bottom, because then it's like 2 negatives, which would make a positive. So you've just undone everything. Always take it to the top. I will always change that to a plus, and then I will change the signs of whatever's after it. Okay, it's me distributing the negative through the top. That's what I've done. Okay, but we like plus signs. Okay, so change it to a plus, and then you just distribute that negative, so flip all your signs on the top after. Okay, does that make sense? I don't want to go top and bottom, because then I've done 2 negatives, which means a positive, which I've not really done anything then. Okay, so through the top. Okay, so we already did step 1, factor denominators. LCD. Common denominator. Take a minute, write it down. Don't say it out loud. Write it down. Write it down. I cannot make them smaller. That's no. That's where most kids struggle. I want one of everything. I need everything. Everything literally on the bottom. Right? I want to a restaurant. What would you like to order tonight? One of everything, please. One of everything.
Remember, you only want food. That's pretty good. Remember, you only want one dish, so there's 2 dishes, you only want one.
Right. All right. So what is my LCD here? No, don't change signs. I literally am going to go work across my denominators. If there was an x minus 5 in here, yeah, I would need that. Yeah, don't make this harder than it has to be. I'm going to work my way across. I need a 2. I need an x minus 1. I need an x minus 3. I already had the x minus 1 down there, right? There was 1 x minus 1, 1 x minus 1. I only need 1 x minus 1. Okay, and that's how, when I work through these, that's what I do. I work from one side, I want to do that, I need that, I need that. Oh, I already got that. But I'm just working my way across, make sure I got everything. Okay? So, step 3, multiply by the missing piece. What is this denominator missing to look like this? It's missing the x minus 3. So that means the top needs an x minus 3. No. You're going to have to distribute that whole thing or do the F word. I'm not going to say it out loud. Watch your mouth. Listen to you guys. All right, so I'm going to multiply. So we have x squared minus 3x. I help you remember things because I'm weird, right? Plus 2x minus 6. Ooh, that's not a 6. What's wrong? I'm distributing.
I only saw x minus 3.
Shut your mouth. All right. All I'm doing is distributing up top. What is this denominator missing to look like this one? It's missing the 2. So that means I have to multiply this top by 2. So we have 4x plus 2. I had to distribute that. Look at all of those pieces on top. Right? What step am I at right now? I just finished which step? Right. I just finished step 3. Now I'm at add numerators. X squared. So negative 3x plus 2x is negative 1x plus 4x is 3x. And then minus 4. Okay, so I just want to make sure everybody's on the same page. I literally just did step 4. I just put my like terms together on the top. Added my numerators. Step 5 is my restrictions. X cannot equal what? Is 0 a restriction? There's no x out here. Just 1 and 3. Just where your x's are. All right, and then factor numerator. Does that factor? Good. Okay, so I just factored the numerator, x plus 4, x minus 1. And then step 7 says to cancel. And I can cancel the x minus 1s. X plus 4 over 2 times x minus 3. And I'm done. Yay. Isn't this fun? Thank you. I think it's fun too. All right, so that was number 10, right? All right, let's go ahead and stop there.